So good morning, everyone, and welcome to this new webinar of the Access series dedicated to technologies, and in particular pilot lines and their collaboration with CHIPS competence centers. My name is Laure de Tassini. I'm a European product manager at Minalogic, and I am very pleased today to introduce the session focused on the APECS pilot line and its collaboration with the ChipNL competence center. Before we start, a few practical and technical points. This webinar will last 1 hour. It is being recorded, and it will be later available on the Access Project YouTube channel. All the participants are currently on mute to ensure the best audio quality during the presentations. But feel free to ask your questions throughout the webinar using the chat. And we will try to answer your questions at the end of each session, but also at the final Q&A discussion. If we do not have enough time to address all the questions, then we will contact you after with the relevant answers. Before we start the technical presentation, I would like to briefly introduce the broader European framework behind this initiative, the Access project itself, and the objective of this webinar series. As many of you know, Europe is currently accelerating its efforts to strengthen its semiconductor ecosystem through the European Chips Act and the activities implemented under the Chips Joint Undertaking, which is also known as the Chips GU. Here, the ambition is clear: reinforce Europe's technological sovereignty in semiconductors, increase innovation capacity, and facilitate the industrial deployment of advanced technologies across Europe. To support this ambition, several strategic instruments are being deployed. The pilot lines, which provide access to advanced technological infrastructures and manufacturing capabilities. The competence centers established in each member state to support companies, especially SMEs and startups, and the design platform, which facilitates access to design tools. The challenge today is to ensure that companies and end users can easily understand, access, and benefit from them. This is exactly where the Access project comes in. The Access project is composed of a consortium of 7 core partners and 14 associated partners coordinated by Blue Morpho. The objective of the Access project is to connect the 30 CHIPS competence centers, the 6 pilot lines, and the design platform to build the European network of CHIPS competence center, which is also known as ENCCC. More specifically, the Access project aims to facilitate the collaboration between ecosystems, harmonize the technology and training offers of all the competence centers, improve the visibility of the available services, and simplify access for European stakeholders. Within this framework, Minalogic leads this webinar series dedicated to pilot lines. And the idea behind the series is very practical. It's to help stakeholders better understand what the pilot lines are, what technological resources they provide, and how companies can access them, and also how competence centers can act as gateways towards these infrastructures. Each webinar will follow the same formats. So 1 pilot line, 1 competence center, and concrete examples of collaboration and end user support. Today's webinar is dedicated to advanced packaging technologies with the APECS pilot line and the ChipNL competence center. And we're also very happy to continue this series in the coming months with additional webinars dedicated to other pilot lines and other competence centers across Europe. Today, this session will provide insights into the APECS technological offer, access strategies to the pilot line, collaboration mechanism with competence centers, and the perspective of ChipNL on supporting the Dutch advanced packaging ecosystem. We are pleased to host Felix Mohn and Eric Jung from the APECS pilot line and Marc-Luc Ferreira from the ChipNL Competence Center. So thank you again for joining us today. And now I am pleased to hand over to Felix Mohn for the introduction to the APECS pilot line. Felix, I give you the floor.
Yeah, thank you. Okay. I start sharing. Okay. Does it look good on your end?
Okay.
Yeah, perfect.
Oh, perfect. Okay. Yeah, so also good morning from my end. I'm happy to be here and to talk about the APECS pilot line today and also our collaboration with ChipNL that has been emerging and growing since last year. And first of all, what is the APECS pilot line briefly about, or what we want to talk about today? Our main goal is to answer the question how APECS brings heterogeneous integration to Europe, or enables heterogeneous integration through design technologies, through testing capabilities, and to showcase how we put systems on a single platform. And we are two representatives today from APECS. As mentioned, I'm Felix. I work for the business office of the research fab microelectronics, and I'm mostly going to focus on some general information on APECS and how you can access our technologies, and also on collaboration opportunities for chip competence centers that I guess are also present here today. And my colleague Eric, who's at Fraunhofer IZM, a large partner of the APECS pilot line, is going to talk a little bit about our key technologies and key innovations of the pilot line, and give you an overview on what technologies are driving the pilot line eventually. Okay, just to give you a short overview, who is implementing the pilot line, because it's sometimes a little confusing as we are not one large institute working on APECS, but kind of like a decentral structure. So the research fab is a cooperation of 15 institutes in total. There's 13 Fraunhofer institutes and 2 Leibniz institutes, all from the field of microelectronics. So we are kind of like spread across Germany, different locations, different clean rooms, also different focuses and capabilities and strength. So Fraunhofer IZM, for instance, is based in Berlin, and they're focusing on microintegration, reliability, very deep into packaging and chiplet integration. That's why they're obviously also working in APECS. But there's also a couple of other institutes contributing to APECS. So also our clean rooms are on different locations, but we all work closely together and exchange wafers. And so this is like a very collaborative project. But we're not by our own. So it's a European pilot line. First of all, I think you all know that there's 5 pilot lines in total, with like different approaches and different focuses. So as mentioned, APECS is coordinated by Fraunhofer and implemented by the FMD. And there's also the 4 other pilot lines. And even though we have different technology focuses, we do have some overlap, and we also work together. So we have joint work packages with Nano IC, for instance, and we have joint work with FAMES. So there's some overlap, and there's also collaboration going on, to make it like a real European effort. When it comes to APECS, and there's also 7 European partners involved. So APECS is a European pilot line. So we got VTT from Finland, we got IMEC, lately as mentioned. We have the Technical University of Graz on board from Austria, INL in Portugal, CNM from Spain, and FORF from Greece. So they all contribute to APECS. We have also joint work package with our institutes, and this is a very valuable partnership. So a few words on the purpose of the pilot line. So why are we doing this? So our goal is to to set up an advanced infrastructure for heterogeneous integration and chiplet technologies in Europe for the European industry. So we are kind of trying to build up the infrastructure and the know-how and the technology that can be used by the European industry to create state-of-the-art semiconductor products, to accelerate their innovative products, and so on. So this is actually for the European industry, and we also grant preferential access to European companies, especially SMEs and startups, to make Europe more independent from Asia, from the United States, and to make Europe innovative again when it comes to semiconductors. And our main goal is, our main focus is advanced packaging and heterogeneous integration, as mentioned. So this is just for an introduction, and I'm now handing over to my colleague Eric, who is more diving into the actual technologies that are driving APECS.
So thank you, Felix, for handing over. So you mentioned two key buzzwords here, which is the heterogeneous integration as well as the chiplets. And we have identified beforehand in consultations, and there were also some CSA projects involved there, like, for example, the PAC for EU, that there are some key challenges to be addressed, like, for example, the design complexity that comes with the heterogeneous integration, as we have not only to deal with the state-of-the-art CMOS devices, but we are also looking into photonic devices, into power devices, into high-frequency devices, or even sensing devices. You have seen some of the previous partners mentioned for the APECS pilot line partner situation. They have specifically the sensors on their roadmap. We have to manage in that context for the design, the electrical and optical coupling. We have to ensure that the co-design for these is going efficiently with respect to keeping the design complexity low, as well as the system complexity low, and the thermal stability, which becomes one of the key metrics here, is also well managed. Another challenge that comes up when you try to put this on a commercial level is that you need to have standardization, so everyone can use some open standards to take up their ideas and use components like, for example, the chiplets, and bring them into their system design. That will require some universal design rules as far as it is possible in a complex heterogeneous system. That will require standardizing of interfaces. That will require that we ensure process compatibilities. Some of you might recall the project, that very early chiplet project from DARPA in the US, where they brought together the various chiplets and were completely unable to manage the complexity of the process, like wire bonding, soldering, direct bonding, and whatnot. And here the process compatibility should be improved. Clearly, we also want to make sure that those systems work as reliable as you know them from the standard SoCs, the monolithic SoCs. So we have to establish reliability benchmarks. When it comes down to manufacturing precision, this is also where we are looking into developing process and assembly design kits. We will look into providing high-density interposers and the respective manufacturing design rules for these. We'll come up with, together with equipment manufacturers, on submicron alignment, looking into process variations and how to control them. One of the aspects, especially if you go to heterogeneous materials, is how can you enable stress-free bonding, like, for example, with the decoupling approach. And it will require also new testing concepts, because nowadays, if you have a complex SoC, you have already some challenges. But if you add, for example, optical components, if you add sensing components, then testing becomes much more critical. Saying that, this shows also that cost management is clearly an issue, because chiplets and heterogeneous integration is not something that is paid for just for itself, just by saying, well, we go for chiplets. We have to show that it is really okay to reduce the fabrication costs, in contrast to today's design approaches. We have to show that improving yield, while this seems to be a clear-cut aspect, especially if you go to the more complex SOCs. But this has to be demonstrated. We have to show that scaling of the assembly processes is possible to reduce cost and ramp up volumes. And this is specifically true for Europe. We have to bring back suppliers to Europe so that we reduce our supply dependency from the Far East, mainly from the Far East. Next slide, please. In order to do this, we have structured the APECS into with various work packages that gyrate around two core concepts, which is the STCO design, that stands for System Technology Co-optimization, that encompasses both the chiplet itself. So how can you build a chiplet that lends itself with full compatibility for the subsequent integration steps, as well as the integration steps themselves? And lastly, and then the second part, how can you ensure that these chiplet-centric designs are characterized, are tested, and demonstrate a very high reliability? And that's not only for the electrical functionalities, but that goes for the optical functionalities, for the RF functionalities. And you see here a buzzword, which is QMI. This is basically a three-dimensional stacking of chip functionalities. So a step towards fully 3D integrated ICs. This is also a challenge that will be addressed at a very early technology readiness level within the APECS pilot line. Clearly, if we go for functional integration and advanced packaging, these also need to be tested and checked so that not only the chiplet functionality, but also the system functionality is working as expected. Next slide, please. We have come up with a picture of a catch it all or jack of all trades mock-up, which has basically all those core technology challenges in one picture, in one 3D design. If you go for the next animation, you see that it's not just on the standard approach where you have components put together, but really you integrate the substrate itself as a part of the functional system. And once again, we have some differentiations in how to approach that, rely on the state-of-the-art separation of the worlds towards wafer level and substrate level. So you see here at the wafer level, I have to tell you that things are in a move. These sharp boundaries, they dilute in the meantime, but notwithstanding, they still hold. And this is why we have, for example, on the wafer level, we look for the hybrid bonding, mostly copper to copper. We have also aluminum, but the industry standard goes for hybrid bonding, miniaturizing these high-density multi-layer silicon interposers, which will be the workhorse of extreme high-density integrated systems. That goes hand in hand with thin film embedded chips, which have a very thin remaining substrate. We look into through X vias, through silicon, through glass, through polymer vias. We want to embed silicon bridge elements as well. Some of you might know the Intel's EMIB approach. And we want also to use the package itself, for example, with its exterior surface, to act as a contributing part of the overall system, like, for example, here, antenna and package using 3D shaped mold caps. Jumping to the substrate level, so this is already the first intersection between the two areas. You see, for example, that we want to use also with the metallic thin film on organic materials. We want to use them also for security aspects, because with the current setting we have in the world, re-engineering electronics sometimes is a differentiation between remaining competitive edge or losing it. And this is where anti-tampering structures come into play. Clearly, we want to continue and push the envelope of embedding passives, chips, or even entire modules, and integrate also optical waveguides for co-packaged optics. And that is depicted also in the next slide. So, for example, the technical targets we want to look at is that we go into very small sub-nanometer I/O integration for 500 nanometer I/O pitch for 3D stacked silicon, either chip to chip or chip on interposer. Also submicron line spaces at 4 multilayers for those interposers. We want to shrink the remaining chip substrate for thin film integration into the 1 micron range of remaining chip thickness. We want to go for high aspect ratio vias in the IC substrate like silicon. This should go to aspect ratio of 20:1. For glass vias, about 15:1. If we look into polymer, that can go for anywhere from 10 to 40:1 aspect ratio. Multi-layer bridging elements should be embedded, and as said, the value-added package, which brings us over to the substrate level. Antenna in package, metal mesh, and obfuscating routing for the anti-tampering, and value added for the packaging. We want to go to embed not only chips and passive, but also panel level packaged SiP, system in packages, so that you have basically here, like, you know, the Russian matryoshkas, you have a package in a package in a package, basically, and the interlink both on the package itself as well as to the outer world will more and more rely on optics that will require co-packaged optics. The next animations show a little bit of what has been achieved in the past, starting basically with the pilot line and ramping that up towards the next level. And Felix, you can just click through the animations that come. So this would be the submicron stop here, the submicron vias, the submicron line spaces, the high aspect ratio vias, the multi-topography, thin film lines, the antenna in package, embedded IC, embedded SiP, as well as the co-packaged optics approach here. Saying that is that APECS started already with a very strong legacy that differentiates it from some other of the pilot lines that really start from scratch. And need to ramp that up already from zero upwards, just based on the expertise. Here we have already several initiatives before that now are interlinked in the pilot line, in the APECS pilot line, and will thereby generate the P80Ks as well as improve what we have in place. Only some small radicals, like for example the QMI, the quasi-monolithic integration, that will be a radically new approach, or the really submicron structures that will require also new equipment, which is currently being installed. Let's go to the next slide. As all of these innovations that we are targeting will not immediately see a commercial uptake by our industrial partners. The idea was to showcase the technical capabilities by demonstrators, which take up the innovations being performed here, and this will be, in fact, 4 different demonstrators, technical demonstrators from within the pilot line. There will be also demonstrators in the collaboration with the other European partners, but they will be mostly dedicated to the needs of the respective European partners. These 4 demonstrators here are specifically to show the technical capabilities that we will achieve, like for example on high performance computing. So this is what where NVIDIA and TSMC right now are dominating the world, and we will bring that back, those capabilities also to Europe. We will see a multi-material sensor approach that will have a silicon interposer, and onto that a multiplicity of sensing and readout devices. Also with edge AI is a buzzword here. But here see also first time that the QMI chiplets with the CMOS plus X components will be integrated. Demo 3 on photonics, showcasing that we will get very, very small integrated, heterogeneous integrated systems for extremely high performant optical component-like devices. And the demo 4 on high frequency, we showcase that for radar as well as for mobile communication that will use panel level integrated circuits, glass core substrates, as well as flexible antennas that can be bent into shape so that you have, for example, a phased array or massively multiple input output system that can be adapted in its three-dimensional shape to get you an improved directionality with improved attenuation or improved RF properties. That brings us to the synopsis of that of the next slide. So the key innovations we want to address is that we want to bring together unique chiplet integration platform for both 2.5 as well as 3D for a multiplicity of components ranging from CMOS to sensors to optics to RF. And bring these together by advanced packaging innovations. That we will offer an end-to-end design flow and a design methodology for system technology co-optimization that will include design for performance, that will include design for yield, for power efficiency and testability, focusing here on the specific needs of chiplets. So here, this is where we will establish together with the various partnerships with design centers like the CCC, for example, that we will get a comprehensive design approach. And we will expand also the heterogeneous integration into that 3D chip era, which is this kind of quasi-monolithic integration for highest performance density. We'll offer prototyping of these kind of high-performance chiplet-based systems for all European partners. So that might be industries in the sector of healthcare, automotive, sensing, but also startups, and clearly also R&D institutions, so RTOs, who will come up, say, for example, with a novel sensor principle. They will clearly also have access and benefit from the APECS findings. We'll build up also a back-end of line interface technology for these kind of MEMS. If you say back-end of line, that goes from really the back-end to the far back-end of line. So really this is done on the wafer scale for the 300 gigahertz, so sub-terahertz frequencies. And last but not least, we will offer this also in conjunction with novel testing concepts and respective technologies, as well as reliability prediction models. So that brings me, I think, to my last slide, because the application areas of the APECS pilot line, they will not be limited to those 6 areas you see here, but these were identified as the most relevant for the European industry so far. We have seen that from the inception of APECS, we see some shifts in the value assessment of the various industries. So clearly, while it's not depicted here, APECS is, according to the European laws, also open for defense industry. But we like to stick here mostly in our external presentations to high performance computing, industrial manufacturing, telecom, medical, AI, and machine learning, as well as sensor systems. So that is now the last slide that comes up now, I think, is handing over to Felix again for the access and collaboration slides. Thank you for your attention.
Thank you, Eric. Are there any questions, like urgent questions, or should we just proceed?
There are no questions in the chat, so we can proceed.
All right. Yeah, I think we got some time at the end of the session for Q&A.
Yes.
Okay, so
yes.
so thanks, Eric, and I want to talk a little bit about how to work with us. So both potential users, so industry, startups, academia, RTOs, and also on the other hand, competence centers. Let's first start with potential users of the pilot line. So you've already seen that there's a bunch of institutes involved in APECS, but we want to make sure you don't have to reach out to each institute themselves, or try to write the right institute or right partner for you to solve your problem. So we've established a one-stop shop at our business office in Berlin, but it's also a virtual office, which basically serves as the first phase to the customer. So you can submit any inquiries through our website, through us, and it will be directed to our access team, which is a couple of people, a mix of like business development and technical experts. And we first like have a look at those inquiries and see what it's about, and usually set up a first like initial meeting to check your requirements, to learn more about the project or the technical needs. And after the initial meeting, we involve technical experts from one of our institutes that are most suitable to the project or can most likely help you. So this will then usually be a second meeting where we talk about the technologies in more detail, and then it will be handed over to the technical teams, and they do the remaining discussions on scope of the project and contract conditions, everything, and finally the project implementation. But first of all, any requests you can submit through our website, and then we will process it and direct it to the right people. As you might have heard, our pilot lines are also having open access calls once a year, which is like a big part of the pilot lines and the open access procedure. Open access call means that we are making the technologies that are coming available visible and accessible for companies. So of course we've started with some basic technologies, and we've been developing more and more technologies, more advanced infrastructure, advanced know-how, but throughout the project timeline, we have more like services and technologies available. And our first open access course started on April 1st, and we have a couple of technologies we are highlighting in 4 different categories. And you can submit the user request also through our website. You can also have a look in those categories and see if there are technologies you want to work with, or you have projects which there might be a fit and where we can collaborate. So this is our current open access call. For instance, we have MPW, so multi-project wafer runs on different platforms and different technologies available currently. So this is also part of our open access call. So please feel free to have a look on the website and see if there are technologies you wanna work with. This is more directed towards our competence centers. So you might have heard of our APECS roadshows or European roadshows. We do like multiple times a year. This is like a chance for us to interact with the local ecosystems and communities in Europe, and also collaborate with the competence centers and the local partners. So we usually pick conferences across Europe that are like relevant to APECS and where we can add value. We try to offer some sort of workshop or session on the conference, like technical workshops, for instance, on chiplet integration. And sometimes we organize networking events. So those roadshows are happening right now. And on the pictures on the right side, you see our first roadshow, which happened in the Netherlands in December. You're going to hear a little more about it later, where we brought experts to the Netherlands to interact with the Dutch semiconductor community. And this is something we want to do like also for the next 3 years. For instance, we have 2 roadshows coming up in June. So we will be at Sensor Decade in Oslo in early June, where we have a APECS presentation, like a 20-minute presentation, and also a booth. And so we will also have a technical expert on board and also one responsible for access. Also, like a week later, we'll be in Stockholm at NordPAC, which is an IMEC Nordic conference. This is also a collaborative event together with the Swedish Chip Competence Center, where we have a networking reception the night before NordPAC and a technical workshop on chiplet integration at the conference on June 10th. So yeah, it would be great to see a couple of you on the conference. Yeah, lastly, we'll have our first large conference this year, which is like organized by the Research Fab Microelectronics, FMD, but will feature APECS and this year taking place in Berlin on September 30 and October 1st. It's kind of like located in between like global international conferences like ITF World and like more technical conferences. So it's kind of like in between. And yeah, and two-day conference, focusing fully on microelectronics. And yeah, and registration opened like 2 weeks ago, I think. Okay, so this was our like short introduction about APECS. So here again, we're funded partially by the European Union and by our federal government as well as our German states. Yeah, just for an overview again on our project partners. And now I'm handing over to Mark Luke. Our close partner from the Netherlands.
Okay. Then shall I? Yeah. 1 second. Okay, so 1 sec. All right. So I'm Mark Luke Farrugia. So I'm here representing the Dutch ChipNL Competence Center. A brief introduction about who we are. We're made up of a number of organizations spread across the Netherlands, and even as a small nation compared to Germany and France, we do have different regions with different specialities, different strengths. And as every nation, we also have to learn how to work together. And that goes even broader than a nation, also as the EU, okay? And these competence centers, their main aim is to foster this kind of collaboration, okay? To make our chip industry as Europeans greater and more sustainable and partially independent. So what we have is the traditional Eindhoven, but also Nijmegen, where Philips Semiconductors used to have its base, which nowadays is NXP, Amplion, Nexperia. Enschede is the organization that I represent from ChipTech Twente. A lot happening in photonics there as well. Delft is traditionally our strongest technical university, and there's a lot of quantum going on there. So yeah, our focus areas as the Netherlands, of course, semiconductor-related equipment. We are all known for ASML, but it's more than just that. Also, what we see is a lot of growing fabless designers, and heterogeneous integration has become more than just a buzzword over the last years. We see a lot of opportunities there. And that's the beauty of heterogeneous integration. You combine different things. We are very strong also in the Netherlands in photonics and quantum, but we also reach out to other strong regions in the EU, and that's the APECS pilot line being one of them. And heterogeneous integration is the platform where we want to integrate in a seamless way the different technology building blocks. So, of course, like most competence centers, what we are focusing on is helping our small companies and SMEs with access to what they need. And of course, what they need is you need access to the technology infrastructure and the great ideas that manage that infrastructure to come up with new technologies. You need, if you want to grow, you have to come up with novel ideas, not with me too ideas. And then, of course, it's always the opportunities in business growth, but also funding. and that's public funding, venture capitalists. The next challenge is always talent. You see all over the world, even in the US, where they want to create new hubs, the first wall they bump into is access to talent. So we are taking that very seriously in the Netherlands, like most European competence centers. And of course, then the promotion and industrial internationalization. Without visibility, you end up in your lab doing nice things that land nowhere. Now, we believe in collaboration. Also, the Netherlands owes its existence to collaboration to avoid the nature taking over. Without collaboration, we just flood. So we started this relationship with APECS, and the idea is to foster connections, new connections that generate new ideas that in turn eventually generate business growth. So we started to engage. We started late last year with 2 webinars, and then we started with the APECS Roadshow, Felix. We had 2 visits. One of them was to the Netherlands, and that is Nijmegen, and also Twente, where Enschede is. These were great opportunities to start creating those connections. Who's doing what? Who's dreaming about what? Because knowing what you're doing today doesn't help you make great ideas for tomorrow. So these kind of information sharing both ways, both from the Dutch ecosystem and also from the APECS ecosystem, that was a great way to start fostering these kind of future collaborations. We also, as a Dutch delegation, went closer by to us in Duisburg, part of Fraunhofer EMS, which is also a partner in APECS pilot line. That was also quite a nice opportunity to further stimulate this kind of connections and collaborative approaches. So we had quite nice pitches by our Dutch SMEs and universities. Also, APECS gave us good presentations about what they are working on. And we had this kind of interactive exhibition, groups brainstorming, talking about what can we do better, what can we do next. So we really like this kind of approach where we face-to-face is way better than a webinar. We can all appreciate that. So then in the end, we as the Netherlands, we have our strengths, we have our ideas, but nobody is an island. And what you see in the Netherlands when it comes to packaging, or specifically advanced packaging, is we're starting to also finally dream big. And that is, and that's also personally myself, it's one of my personal missions, is how to bring back, in significant terms, packaging back to Europe, manufacturing. You can only do that with technological breakthroughs that will allow this European packaging, not only for small niche markets, but large volumes, medium and large volumes. You can only do that if you make it economically viable for it to be done in Europe. And that can only be done with technological breakthroughs. There's no other way than collaboration between great minds to make that happen. So the strategic alliance that we have with APECS is important for us as Europeans. And finally, our politicians have woken up. I've been 30 years in packaging, hearing that packaging in Europe is dead. Now, finally, I'm starting to hear. Yeah, I see Eric laugh. Yeah. So finally, at least we're all appreciating that we have a need to do it and it can be done. It will only be done with collaboration. So that is basically my my presentation for today. Yep.
Thank you very much, Mark. And thank you, Eric and Felix. I don't see any questions in the chat, but maybe if you have questions, do not hesitate. Oh, there's one. There is one from Grigory's Disease. For the current open access call, closing June 30th, what is the expected financial contribution from an RTO? Is the service fee fully covered by the ChipsGU grant?
Yeah, I'm gonna take the question. So yeah, this is always a little confusing because sometimes open access, so yeah, it sounds like free access, but of course they're unfortunately they're not free. So like those services are like, let's say, charged on a costly basis done by partners or the institutes. So I know this is like kind of challenging, especially for startups. So we've always been thinking like how to best like support startups that of course are like limited in budget. So one approach was the establishment of the EuroCDP platform that's also there to support SMEs and startups. Also the chip competence centers are also there to support small companies with like funding. So when it comes to consulting, and also to help them to apply for like state funding. For instance, we've done that with the Swedish competence center. They are supporting SMEs with their applications for like a funding program, and we as APECS are trying to hand in documents, anything they need to make this funding happen. So this is like the approach we currently running. Yeah.
Thank you. Tony is asking if we could share the slides after the webinar, if you're okay.
Totally, yeah.
So you can send them to me. I will share with the participants. Okay, any other questions? No. Yes. Yes. Siboni, maybe I can open your microphone somewhere. Now you should be able to open your microphone, Siboni. Henrik.
Oh,
yeah.
Great. Thank you very much. I put my questions in the questions and answer section.
Oh, sorry.
But I can also just say it now.
Yes, go for it.
So I wanted to ask, so what is the process flow for a Dutch startup that would benefit from using the APECS pilot line? So do they go directly to APECS, so the email you presented earlier, or do they go via ChipNL for preparation? I'm asking because usually in these ChipsGU presentations, the competence centers are presented as the first entry point. So I would just like you to clear that up. Thank you for the presentation.
Well, maybe Felix, I can help. We haven't really made a strict rule there, to be honest. So any startup, any company is free to go on the APECS pilot line and submit a proposal. But of course, we would highly recommend to come as an entry point to the competence center. In the end, the startup will still have to do the proposal via in the APECS pilot line, but we as the competence center are there to help. So that would be the recommendation, but nothing prevents anyone bypassing the competence center, to put it that way.
Yeah, maybe to add to this, it also depends on like how clear your requirements are already. So as you know, there's like 5 chip pilot lines, and there's also like other initiatives. So the competence center, they usually have an overview on all pilot lines and all European initiatives. So if it's not clear yet what would be the right solution for you, the competence center are like great help. But if you already know you want to work with APECS because this is like a great fit, you can approach us directly. Yeah, that's what I would say. Yeah.
And Felix, as you said, the competence center is also there to guide the companies with access to funding, being private, public, because in the end, there's a price tag, right, to any activity. Okay, I hope that answers the question. Okay.
Yes, thank you very much.
Yeah, there is another question in the chat from Andrew. There are already 2 large OSAT, one large in Portugal and one Singapore startup well-funded for Italy. How will Europe work with these companies? Who could provide a scale? How is the plan not to collaborate with ties to Asia?
Eric, you want to
go? I might pick up that question. So we're well aware of those OSATs. In the beginning of the APECS pilot line, we had also discussions with those OSATs. Their focus is mostly on ramping up existing technologies, and APECS will get cutting edge in the really advanced stuff which I showed to you. So there is not yet any definition, but by definition, not yet any collaborative approach, say, for example, for a process transfer being initiated, albeit the contacts are in place. And those OSATs, they will typically look into the market evolution. If there is a substantial demand on these kind of novel technologies, which, for example, APECS can provide to start with, then they will immediately raise their hands, and we are ready to share information, design rules, PADKs, together with ChipNL, for example, with them to make sure that they are compatible with the evolving ecosystem here. We do not have, for example, strict plans not to collaborate. That's the second part of your question, not to collaborate with Asian partners. But there is a clear restriction imposed also by the European Commission that we have to ask for permission to collaborate with entities outside of Europe. So that clearly gives an access barrier for, say, for example, for Chinese juggernauts to hop on and pull out all the technologies here. But Europe might have a different standing if it comes to collaboration with what you mentioned here, with, for example, in Singapore or with Taiwanese or Philippine companies. But the main goal of APECS clearly is to enable reshoring of those capabilities to Europe. And I think every scientist, every business developer here in the APECS, as well as in the other pilot lines, is very well aware and also very eager to support that goal.
Yeah, so in general, we are, of course, a pilot line for Europe, but we're also open to work with other countries, especially that are associated to Horizon Europe. So, of course, the majority of the collaborations should be within Europe, but we are open to work with Canada, for instance, South Korea, and those countries. There's some countries we have to double check with Chip Zero that might be a little critical, but of course, we are open to collaborate with like friendly states, let's say it like this. Yeah.
And Andrew has a complementary questions. Is asking a license model for scale up in Europe. Maybe Andrew, you can open your microphone if you want to discuss a bit further.
Hi there. Yes. It's first of all, thank you for the presentations and the material. It's exciting. I too have been around packaging for 30 years, and I think this is a fantastic initiative. So I already applaud the hard work that's gone into getting to where we are today. It really is meaningful and exciting. So my question is really, I currently work with representation, but also consulting firms who work with fabless and startup companies are starting to look at these technologies. And so it then becomes a decision on an interesting technology, but the route to sustainable qualified interconnect sources that can then scale in the medium term is something that obviously we want to do it in Europe, and maybe there's a smart way to do that by pulling some of that expertise into Europe as a baseline so that the complementary new technologies can move faster. So that's what was behind my question, because those big guys have their own initiatives, and maybe there's a collaborative way to be smart but also grow Europe. Thank you.
Thank you. There was a comment and questions from Jade. Jade, if you want to open your microphone.
Hello, do you hear me?
Hello, yes.
Oh, thank you very much. Well, special thanks to Mon and Mark for their presentations. So I have a couple of small questions. So since one of the most important tasks we have in APECS Spain is to give support and guidance to SMEs, and taking into account that the packaging is a very important step, I would like to know what is the TRL range, the TRL range to can access to the services of the pilot line. And the other question is if it's possible that chip competence centers act as an access gate to the pilot line. Thank you very much.
Okay, yeah, thanks for the question. So maybe starting with the last question. So I think this is, let's say, of course, the competence centers should, in my opinion, work as an access gate to the services, and maybe there's also like one reason also of this webinar to give chip competence insights in the pilot line to help them like understand what the pilot line is about, so that they are able to represent it on a very like superficial level to their ecosystem when there's like SMEs approaching or questions coming up. So our goal is like to let's say educate the competence centers as best as possible, so that they can also act as an gateway to APECS. Yeah. So that would be like the vision, I'd say. So we're also open to do like also separate sessions with competence centers to answer any questions they might have on the pilot line. Regarding the TRL level, I'm not the expert in this. I mean, we're basically, first of all, we're taking any questions from startups and universities for like very early ideas or research projects, where we first start with workshops, building a concept, and then we have like potential users, larger companies that are already have like established products where they need to like improve or advance. I don't know, Eric, if you have anything to add to this.
Yeah, I might add one thought, which is once again driven by administrative requirements. The pilot lines should limit themselves to a maximum of a TRL 6. This is due to the fact that when you go beyond TRL 6, we might run into a competitive situation with companies who start serving the market. This is, for example, also the reason why just a couple of weeks ago, the lab to fab call was opened up to bridge that gap between what the pilot lines should be able to offer, as well as the actual industry needs. On a direct basis, when you look into something that goes beyond this TRL 6, where the pilot lines with their own activities should stop. Clearly, you can collaborate with on a specific topics or on a specific topic, also to improve that TRL to higher maturity degree, and thereby pretty quickly, because the know-how is already there, come to something that is ready for scale. And this is likely also a question that is currently being discussed with the ICFO's led APECS Europe pilot line. I think this is where APECS Spain is also interfacing with, because, well, you're pretty close by, I think. But that this kind of TRL limitation imposed by DG competition, that this should not limit the European industry to access that know-how and expand it to higher maturity levels.
Thank you very much.
Okay, the webinar is going to an end, but maybe there is one last question from Ariane regarding the MPW runs. Is there an open access PDK available for people to explore the available technologies?
Yes, Eric is already nodding. Yeah, so we have PDKs, ADKs available for the MPW runs. Yeah, if I'm not, they are available.
Okay, and sorry,
they should be part of the open call. They should be part of this open call that you can access these MPW design rules and the respective design kits. If you look into the, I think Felix shared that before, that this is a part of these calls, because clearly you need to know what you can work with.
Okay, thank you. I see there is a hand raised, but maybe, we'll have to close the webinar, or maybe Jean, if it's a small question.
Yes, thank you. So, how many advanced packaging company or projects we have currently in Europe? Could you give a short introduction? Thank you.
Mark, Eric, you want to?
Yeah, it depends on what you think of advanced packaging. If you take a look at Portugal, for example, with the Amcor site over there, they do pretty advanced things, but not at a level that is, say, for example, comparable what Apple and NVIDIA are requiring from their supplier TSMC, or what Intel is going to show in their US fabs. As we might see in a period of time, we might see that the ESMC, so the European Semiconductor Manufacturing Center located in Dresden, which is a subsidiary of the TSMC, will not only produce the previous generation of IC, but also offer packaging solutions for that. This will clearly be something that is advanced in that sense. APECS looks into that. But we should make sure that we understand that advanced packaging is currently, if you look out to the world, is mostly dominated by the idea of CMOS packaging only. And what APECS is striving to do is really go into the system idea and offer advanced packaging solutions at this point. And if you look to this is limited to RTO so far.
Okay, thank you very much. The webinar is coming to an end. Many thanks to our speakers today, Eric, Felix, and Marc-Luc. The next webinar of the series will be on the 9th of June and will be dedicated to the Nano IC pilot line and the collaboration with the FC3 Belgian Competence Center. And if you want to register, then I just put the link in the chat. Many thanks again for you, all the participants, to have participated to this webinar. And if you have more questions, then do not hesitate to contact us, and we will forward the questions to our speakers. Many thanks.
Thank you.
Bye-bye.
Thank you for joining.
Thank you all.
Bye.